Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximise, minimise and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hi and welcome to the second section of our Azure Virtual Training Day on Hybrid Cloud Infrastructure. Today, we've got two sessions to talk about. The first, which I'll go into in a minute, is all about hybrid cloud applications and data. The second is about hybrid cloud security. So, in this session, we're going to talk about hybrid cloud applications and data and how you can think about where do I put different tiers of the application. Do I put it up in the cloud? Do I put it on-prem? And what are the things that I need to think about when I'm actually doing that? Let's get into the session. In this session, we're going to talk about hybrid cloud applications. So Tailwind Traders has a number of applications that they're going to have to think about what they're going to do when they move to this hybrid posture. Some of the applications, it makes sense to move entirely to the cloud. And some of them, for a variety of reasons, they want to keep the data on-prem. Maybe they want to keep the application on-prem. So in this session, we're going to talk about all of the hybrid technologies that you can use with applications to make them work. Not just migrating the entire application lock, stock and barrel to Azure, but instead how you can have a hybrid application where parts of the application might run in Azure, parts might run on-prem, or where the application runs on premises but is accessible to clients out on the internet where they access that application through Azure. So let's talk about Tailwind Traders' hybrid cloud application requirements. Basically, their hybrid requirement is that they need to keep some workloads on premises and move some workloads to Azure. And there's a variety of reasons for this. Some of the data that they've got stored on premises needs to be kept on premises simply for regulatory reasons. They can't go and put it into the public cloud. And there can be a variety of reasons for that. This is definitely something that you have to deal with when you are living outside the United States. And of course, Azure is owned by an American company. And that means that there might be compliance requirements about where the data can be and how the data center can be managed. And in different jurisdictions or different geographies, that is handled in different ways. The communication between on-premises and Azure needs to be secure and reliable. If an application is in a hybrid posture, what it cannot be is able to be intercepted if the traffic is passing from on-prem to Azure. So one of the other things that we're dealing with in this particular session is this question: which hybrid application technologies is appropriate for Tailwind Traders to use in a given set of circumstances. So when you walk away from this session, what you should be able to do is be able to identify which technology is appropriate for a given scenario. So Tailwind Traders has the following specific requirements. The first is, how can Tailwind Traders make applications that run on their internal network available to the internet without opening inbound ports on the perimeter firewall? The next question is, how can Tailwind Traders retire their current perimeter network and reverse proxy? That is, at the moment they are publishing some applications that sit on their perimeter network out to the internet, and clients on the internet access those applications through the perimeter network firewall because those applications are sitting on the perimeter network. What Tailwind Traders really wants to do is shift those applications up so that those applications still sit on an internal network, but instead of having a perimeter network, the traffic comes in through Azure. Now, as part of their application modernization strategy, Tailwind Traders has moved some of the web tiers of their existing applications up to Azure. So instead of running on IIS, what these applications are doing they're now running as web apps. But what Tailwind Traders wants to do is wants to be able to allow these web applications to use on-premises data sources such as SQL Server that's running on-prem. Eventually, they're intending to migrate some of these SQL Server databases into Azure, but at the moment they're very large and there is some issues around migrating those databases. So what they want to do is they want to have the front end sitting in Azure and they want to have the back end sitting on-prem. So the next thing is they want to simplify the management of on-premises Kubernetes clusters. At the moment, they're running Kubernetes clusters using Windows containers, but there's a Linux infrastructure that basically serves as the command and control for those Kubernetes clusters. And this was very difficult for Tailwind Traders to set up. And the person that set that up has left the company and is working for someone else. And basically, it's very hard to replace that expertise. So what Tailwind Traders would like to do is come up with some way of simplifying the management of their on-premises Kubernetes clusters. Similarly, they want to simplify the management of their on-premises SQL and Postgres SQL instances. Again, that person that set all of that up has left the organisation. They don't have the necessary experience with management of those databases. They've got people that know how to develop them, but they don't have the sort of IT operations experience with those particular products. So let's talk about hybrid cloud applications. What is a hybrid cloud application? Well, the easiest answer is a hybrid cloud application is an application that runs in the cloud. But practically, what a hybrid cloud application is an application that might have one tier in the cloud and another tier on premises. Maybe the front end's in the cloud and the back end's on-prem. Now, moving to a hybrid cloud applications allows organisations to retire the perimeter network whilst keeping some of those applications in on-premises data centres. Now, the reason that they want to do that is if you think about one of the biggest security risks to an organisation, it's the perimeter network, simply because a lot of perimeter networks aren't particularly well configured and they require a lot of expertise to run and to monitor. If you can delegate that away to Azure, then you're probably saving your organisation a lot of money in the long run. The other thing that you might want to do is you might want to allow application access to applications hosted on-prem on an internal network without requiring a virtual private network. One of the things that we learned in 2020, especially when people were working from home, was that it was often very challenging to allow them access to line of business applications that were running internally without setting up a complicated VPN or a remote desktop infrastructure. So one of the things that Tailwind Traders would like to do as a part of their hybrid cloud posturing is allow access to those internal applications that might require, for example, Active Directory authentication, but allow access to those through Azure rather than setting up a VPN server on the perimeter network and allowing remote access through a VPN server. Instead, is there a way to publish those applications so that Azure can take care of all of the bits and pieces that allow access to that internal application? So in this session, we're going to look at Azure Relay. We're going to look at Azure App Service Hybrid Connections. We're going to look at Azure AD Application Proxy. We're going to look at Azure Arc-enabled Kubernetes and Azure Arc-enabled data services. So the first technology we're going to look at is Azure Relay. In previous iterations of this technology, this was sometimes called Service Bus Relay and also was related to BizTalk. Anyway, so what does Azure Relay do? It allows you to securely expose workloads that are running on your internal network to the public cloud. Now, a way a lot of these technologies work is that you essentially install an agent on-prem, that the agent on-prem reaches out to Azure and creates a secure connection to Azure. It doesn't go through your VPN. You can have a single agent on-prem, and that can actually reach out to a variety of different hosts that are on-prem. So from the agent to Azure, there is an encrypted connection, but it's not a traditional site-to-site VPN. Now, the other benefit of Azure Relay is it doesn't require you to open an inbound port on your perimeter network firewall. So the agent establishes an outbound connection rather than Azure establishing an inbound connection. It also allows you to publish applications to clients on the internet, whereas the endpoint will be in Azure, without configuring a VPN connection. Now, there's another technology we're going to talk about a little later in this session called Azure Active Directory Application Proxy. And you use Azure Relay when your application doesn't require Azure Active Directory authentication. If it does require Azure Active Directory authentication, fall over and use Azure AD Application Proxy. If you've just got an on-prem application that you want to publish to the internet, then use Azure Relay. So Azure Relay supports the following scenarios between on-premises services and applications running in Azure. It supports the traditional one-way request response and peer-to-peer communication. It supports event distribution to enable publish and subscribe scenarios, and it supports bidirectional and unbuffered socket communication across network boundaries. There's two types of Azure Relay. There's hybrid connections, and we will be coming back to hybrid connections when we look at app service hybrid connections, and they're very, very similar. They actually use the same technology, but here, when we're talking about Azure Relay, we're talking about the whole app being on premises. When we're talking about hybrid connections, we're talking only a tier of the app being on premises. So with hybrid connection, it uses open standard WebSockets, and it can be used across platforms. So with hybrid connections, you can have an on-prem app running Linux, you can have an on-prem app running Windows, and it doesn't matter. You can use a hybrid connection to publish that application so that it's available to clients on the internet through Azure Relay. There's also the Windows Communication Foundation relays. So WCF relays use a Windows Communication Foundation to enable RPC or remote procedure calls. This is an existing option that customers use with their WCF program. It also supports WCF Relay, which is what this technology used to be called, as well as the .NET framework. Now let me talk you through the process that is illustrated in this diagram. Step one is that the listening client sends a listening request to the Azure Relay service. An Azure load balancer will route that request to one of the gateway nodes. In step two, the Azure Relay service will create a relay in the gateway store. In step three, the sending client sends a request to connect to the listening service. In step four, the gateway that receives the request looks up for the relay in the gateway store. In step five, the gateway forwards the connection request to the right gateway mentioned in the gateway store. In step six, the gateway sends the request to the listening client for it to create a temporary channel to the gateway node that's closest to the sending client. In step seven, the listening client creates a temporary channel to the gateway that's closest to the sending client. Now that a connection is established between clients via the gateway, the clients can exchange messages with each other. In step 8, the gateway forwards any messages from the listening client to the sending client. And in step 9, the gateway forwards any messages from the sending client to the listening client. So what I'll do now is I'll show you a demo of how we actually set up Azure Relay. So here we are in the Azure console. I go to the search bar and I type Relay. I click on Relays. So we can see here that there's already a relay, and that is an app service relay. I'll talk about those a little later in this session. What I'm going to do is I'm going to create a new relay. So I select Add. This gives me the create namespace. So what I need to do is create a service bus namespace. I select my subscription and my resource group. In this case, I'm selecting the resource group TWT Relay. Now, the service bus namespace must be unique in the world. So in this case, I've just called it TWT Relay servicebus.windows.net. Now, it will perform a check for me, and you'll see that little green check mark saying that it has validated that no one else is using that particular name. I specify my location. Here I'm specifying as East US. I click Review and Create, and it creates that Service Bus Relay namespace. The deployment's in progress, and the deployment succeeded. So I've created the Service Bus Relay namespace for this relay. Once I have done that, I can go to the resource, and what I can do is I can add a hybrid connection or a WCF relay. So if we select here on entities, we've got no hybrid connections for this relay at the moment and no WCF relays for this service bus connection at the moment. So I go back to hybrid connections and I add a new hybrid connection. All I need to do is provide it with a name and select whether or not it requires client authorization. I'll be able to connect to these later with my application. So we can see that we've got TWT Web App, and there I can see the hybrid connection URL that is used when using that relay. I can select WCF relays. I can add a new WCF relay. Now, I can choose between NetTCP and HTTP in the relay type. And the one that you will choose will depend on how your WCF application is actually configured. I click Create. It creates that WCF relay. I can see the relay there, and by selecting the relay, I can see the properties of that relay. So here we see the namespace, the WCF relay URL, whether or not it requires client authentication, and the number of listeners that have so far been configured for it. So in that demonstration, I showed you how to configure Azure Relay with a WCF relay and a hybrid connection. So the next technology I wish to talk about in terms of hybrid cloud applications is the Azure App Service Hybrid Connection. So the idea of this one is rather than, as we did in the first one, we created a full relay from Azure to your on-premises application. With an Azure App Service Hybrid Connection, what it allows you to do is allows you to connect an Azure web app, obviously running in Azure, to an application resource on any network that is able to forward outbound requests to Azure on port 443. So that could be a virtual machine running on premises. It could be a virtual machine running in someone else's cloud. Any resource that's able to send outbound requests. It can communicate with any resource provided it can function as a TCP endpoint. So clear and important here is that it's TCP rather than UDP. So the way that it works is you use a relay agent. You install a relay agent. That relay agent sits on your internal network and has direct line of sight to the data source, as long as that data source has a TCP endpoint. So it can be a SQL database, it can be a MySQL database, it can be a Postgres SQL database. Anything that functions as a TCP endpoint can be used with Azure App Service Hybrid Connection. Again, with this technology, it's not necessary to open an inbound port on your perimeter network firewall. And of course, it doesn't require that you have a VPN or an express route connection. So in this diagram, you can see that you've got a web app running in the cloud. You've got a system that's running on premises that's hosting the Relay Hybrid connection. Now, if you want, you can have the Relay Hybrid connection on the data source itself, which is what I'm going to show you in the demo, or you can have the data source on another system. For example, you can then configure Hybrid Connection Manager to connect through to the endpoint, such as a database. So what I'll do now is I'll show you a demo of setting up Azure App Service Hybrid Connection to configure a connection between a web app running in Azure and a database running on a VM on premises. So we start here on our VM. And what I'm doing on our VM, and this VM's running on premises, is I am verifying the IP address configuration. We can see it's 192.168.0.33. This is important for when we're setting up our endpoint. The thing I'm showing you here is that we've got a SQL database installed on this specific virtual machine, the one that's 192.168.0.33 as its IP address. Now, we're going to configure it so that a web app can go and talk to this virtual machine that's running on-prem. So to do that, what I do is I switch across to Microsoft Edge, and you can see here that I've opened up an app service. And this app service is called TWT HYB app, or Tailwind Traders Hybrid Application. So in the properties of this app service that we're looking at in the Azure portal, we scroll down, and under settings, under TLS SSL settings, we can see that there's a networking section. And this section has VNet integration, hybrid connections, and Azure Front Door with Web Application Firewall and Azure Content Delivery Network. So what we do is we select hybrid connections, configure your hybrid connection endpoints. And on this page, we've got the option of downloading the Connection Manager software. So we select Download Connection Manager. We get the Connection Manager MSI installer file. We open that file. We get the start of the Hybrid Connection Manager setup wizard. So I accept the terms of the license agreement, and it goes and installs the Connection Manager software on this on-premises system. Now here, I click Finish. What I've chosen to do is I've chosen to put the Connection Manager software on the same server that's hosting the database. Now, I don't need to do that. I could do it on another server as long as it's got TCP connectivity to the server that hosts the database. So the next thing I'm going to do before I run the Hybrid Connection Manager is I'm going to add a hybrid connection. So I click Create New Hybrid Connection. I provide a name for the hybrid connection, in this case TWT SQL on-prem. I must provide an endpoint host. Now, the important thing about setting up the endpoint host is that the endpoint host address needs to be resolvable from the system that you've installed the Hybrid Connection Manager on. So it can be an IP address or a fully qualified domain name, but it needs to be an IP address or a fully qualified domain name that can be resolved from the computer or the host that has the Hybrid Connection Manager installed. So in this case, I just put the IP address 192.168.0.33. The next thing I do is I put the endpoint port. In this case, it's SQL, so I put 1433. The next option I've got is whether or not I want to create a brand new service bus namespace or select an existing service bus namespace. So we saw when we looked at the Azure Hybrid Connection that we actually created a service bus namespace for that one. This is a very similar technology, but instead of just doing a connection down from Azure for the whole app, in this case, we're connecting an app service to a particular TCP endpoint on-prem. So to make this as simple as possible, what I'm going to do is I'm going to create a new Service Bus namespace. I'm going to create it in the East US Data Center, and I'm going to provide it with the name TWT SQL On-Prem. I select OK. It creates that hybrid connection. Once that connection is successfully created, my next step is to go back to the computer that I've installed the Hybrid Connection Manager on. So I select Hybrid Connection Manager UI, and I'm going to add a new hybrid connection. So I need to sign in to an account that's got permission to this resource. That's primeadmin and tailwindtraders.org. I click Next. I provide my password, and I sign in. It logs in and it says select a subscription that you're associated with. I select a subscription. And what it does there is it performs a query on all of the hybrid connections that are configured for that subscription. So you just saw me create one where I specified that IP address, and you can see it there, 192.168.0.33:1433. It's important that you configure that addressing when you set it up in the cloud, so that when you're on-prem and you're selecting that, it knows all of the plumbing and the routing that it needs to use to connect to that TCP data source. So I select that item, I select Save. It saves that item, and then what it'll do is it'll establish the connection. So we can see now that it's got a status of connected, and we can go in and view that connection details. We can see where it's connected to. We can also see the Azure IP address that it's going out and connecting to on the internet, as well as the Azure ports that it's using. So in Azure, it's 191.236.32.191, and it's using ports 80 and 443 on that host in Azure. It's also connecting to the internal IP address, 192.168.0.33, port 1433. So it's created a connection between those two locations. So I close that, I minimize that, and I can see that it's listed as connected in the Azure console, and I can see the Service Bus namespace and the properties of that hybrid connection. So in that demonstration, you saw me configure a app service hybrid connection that configured a connection between an app service and an on-premises data source. So now that that is configured in the app service, I can configure the app running in the app service to access that connection just based on the name here, TWT SQL On-Prem, because as far as the app in the app service is concerned, that connection exists and it doesn't care where that resource actually is. So that allows me to connect that app service, app running in Azure, with that on-prem database through that hybrid connection. So the next technology I want to talk about is Azure Active Directory Application Proxy. So the idea of this technology is it allows you to provide secure remote access to web applications running on an on-premises network through an external URL. That is, that clients on the internet use an external URL. They authenticate using their on-prem Active Directory credentials, which are replicated up through Azure AD Connect to Azure. This can be used as a replacement for reverse proxies or VPNs. There's a lot of organisations, as I mentioned earlier in the talk, who are publishing applications through VPN, where someone's got to authenticate to their VPN, and that gives them a connection into an internal application that's running on-prem. And you can configure this so that it can use remote access and single sign-on to web applications that use integrated Windows authentication, web applications that use header-based or forms-based authentication, applications hosted through remote desktop gateway, and on-premises SharePoint. So, in this particular diagram, let me talk you through how this works. In step 1, the user connects to the application through a publicly available endpoint. When they do that, they perform Azure Active Directory sign-on using their on-premises credentials. Step 2, a token's forwarded to the user's device after the sign-on completes. In step 3, the client device forwards that token to the application proxy service. That proxy service returns the user principal name and security principal name from the token. The application proxy then forwards the request to the application proxy connector. If single sign-on is enabled, the application proxy connector performs additional authentication. In step 5, the application proxy connector forwards the request to the on-prem application. And in step 6, the response is sent through the connector and the application proxy service to the user that's sitting in front of their browser on the internet. In this demonstration, I'm going to show you how you set that up in Azure. So important to understand, just before I start the rest of this demonstration, is that this environment already has on-premises Active Directory domain services configured to replicate to Azure AD through Azure AD Connect. That is necessary before you take this next step. Now, the other thing about setting this up, especially on Windows Server 2019, is that there's a number of steps that you must take before you configure the connector software. And these involve editing the registry. So I click the Start button and I go into the registry editor. I run it as administrator because I want to edit the registry. So here we need to create some keys and modify some existing keys. So the first key is HKey local machine, software, Microsoft Windows, current version, internet settings, WinHTTP. And here I'm just using a bit of PowerShell to actually create a HTTP to default enable key. And we set that set to 0. The next thing we need to do is we need to go in HKey local machine, system current control set, control security providers, S channel or secure channel protocols. And what we need to do is we need to actually create some keys and set some registry entries. So what I do first is I create a new key, and that key is called TLS 1.2. And a key is basically a folder in the registry, if you want to think of it that way. So within that TLS 1.2 folder, I create a D word, and the D word is disabled by default, and I leave that at the default setting of 0. I then create a new registry entry, another D word, and this one is enabled, and I set the enabled value to 1 to turn that on. I then create a new key under TLS 1.2, and this one is called server. So within server, I create the same registry items that I actually created under TLS 1.2. So the first one is disabled by default, and that's set to 0. The next registry item is enabled, and we set the value of that to 1. Then we navigate to the final area of the registry that we need to configure. And again, this is a little more into the weeds than it usually is when you're setting things up to work. So here we go into the .NET Framework registry. We go into the version 4.0.303.19. We create a new registry entry called SCH use strong crypto, and we set the value of that to 1. Once we have configured all of those registry entries, and we have to do it manually, even on Windows Server 2019, we need to restart the server. So we restart the server reboots, and those registry entries will take effect. Some registry entries take effect automatically, some it's better just to actually push through a reboot. So now that we've performed the reboot and we've signed back on, what we're going to do is we're going to open up Microsoft Edge. We're going to sign in as prime admin at tailwindtraders.org. We put in our password. We're in the Azure portal. We go to Azure Active Directory. We scroll down and we select Application Proxy. So, Application Proxy does require Azure AD Premium. We've already got that configured. Next thing we do is we download the connector service software. That downloads the connector service software executable. I click on that. It starts the installation wizard. I accept the license terms. I click install, and it runs the Application Proxy installer. That requires me to again sign in with an account that's got appropriate permissions to Azure Active Directory. It needs global administrator permissions to do this. I click sign in. It then configures the connection between this particular system and Azure Active Directory. So if I do refresh, I can see here that I've got a connector established, and once I've got a connector established, I can configure a new application. So I give the application a name. This is the internal Active Directory Authentication app. This is the internal URL that is resolvable from the machine I just installed the connector on. It's just HTTPS internal app. We can see that it's given me an external URL, and we can configure some additional settings. So HTTP cookie only, whether it requires secure cookie, persistent cookie, translate URLs between the internal app and the external app that clients will be accessing this application to from the internet. So if we look at the properties of this application here, we can assign users and groups to that application. We can turn on single sign-on. We can provision user accounts. We can configure a custom policy, and we can configure whether or not that's self-service. If we go to properties here, we can see the homepage URL of that particular application. And the user accessible URL, the application ID, whether or not user assignment's required, and all of the other settings that you would configure for this application in the same way that you would configure an application that was running just in Azure. Okay, so the next technology I want to talk about is Azure Arc-enabled Kubernetes. So, what Azure Arc-enabled Kubernetes does is, instead of installing a Linux head node to run your Windows Server containers, what it does is allows the management of Kubernetes running on-prem through the Azure portal. So it's a lot simpler because you're just running Kubernetes through Azure being your control node rather than doing it through basically hand-built Kubernetes. It allows you to connect Kubernetes clusters outside of Azure, and you can perform inventory, grouping, and tagging tasks. You can deploy applications and apply configurations to Kubernetes clusters using GitOps-based configuration management. You can use Azure Monitor for containers to review and monitor your hybrid Kubernetes clusters, and you can apply Azure Policy for Kubernetes policy to hybrid Kubernetes clusters. You can see in this diagram, we've got Azure on one side and we've got Azure Arc-enabled Kubernetes clusters. Now, the advantage of Azure Arc-enabled Kubernetes clusters is all of the plumbing for that is done for you automatically by Azure Arc, which means all you have to worry about is deploying the application, and all of the Kubernetes management itself is handled by Azure. The next topic I want to talk about is Azure Arc-enabled data services. So what this allows organizations to do is to run Azure database for Postgres SQL servers and SQL managed instances on-prem. So what that means is, instead of you being responsible for managing your Postgres SQL servers or SQL Server, you can do what you do in the cloud, which is you allow Azure to manage Postgres or Azure to manage SQL Server, and you just worry about running the database on it, so that it's running it on-prem in a virtual machine, except for you're not worrying about the care and feeding of that VM. That's being handled by Azure Arc. You can manage it through Azure Data Studio, Azure Portal, or the Azure CLI. And the advantage of this is it automates the patching and update processes for these on-premises database instances. As I said, you just worry about running the database. The database engine and the operating system that hosts the database engine is all updated and managed automatically by Azure Arc. It also, when you light this up, applies Database Advanced Threat Protection functionality in Azure Security Center for managed SQL instances on-prem, which means that you get all of the security configuration and all of the security monitoring functionality of Azure Security Center for when you would use those things in Azure for your on-prem instances. It also uses container and Kubernetes services to host the managed databases instance. This is the way that it does it. So it's not actually deploying a VM, it's deploying Postgres and SQL in containers, and the containers themselves are being managed by Azure Arc. Anyway, in this session, I talked about how you could use Azure Relay to make internal applications available to the internet without having to open inbound ports on your perimeter firewall. In this session, I showed you how you could use Azure AD Application Proxy to allow Tailwind traders to retire their reverse proxy for applications that required on-premises Active Directory authentication. In this session, I talked about how you could use Azure App Service Hybrid Connections to allow Azure Web Apps to use on-premises data source. In this session, I talked about how you could use Azure Arc-enabled Kubernetes to simplify management of on-premises Kubernetes clusters. And I talked about how you can use Azure Arc-enabled data service to simplify the management of on-premises SQL and Postgres SQL instances. On this page, you can see an additional set of resources that'll take you to docs.microsoft.com and actually allow you to see in much more detail how to use Azure Relay, Azure App Service Hybrid Connections, Azure AD Application Proxy, Azure Arc-enabled Kubernetes, and Azure Arc-enabled data services. Thank you very much for your attention. Okay, so in that session, we looked at hybrid cloud applications and we looked at hybrid cloud data. Now, we're going to take a break for 10 minutes, and when we come back from the break, we're going to look at hybrid cloud security. Hope to see you in the session.